Welcome to this explainer. Today, we are doing something totally different. I want you to imagine you are a paleontologist. Seriously, stick with me here. When a paleontologist goes out into the field, they don't just look at the surface of the dirt. They have to dig through the complex fossil layers, carefully brush away the confusion, and reconstruct the full, perfect skeleton to understand the whole picture. That is exactly what we are going to do with one of the most notoriously misunderstood areas of the Cambridge Information Technology syllabus. We are going to dig through the complex layers of exam question parts, brush away the irrelevant details, and reconstruct the full, perfect, top-tier answer for Section 3.1, which covers light, UV, temperature, and pressure sensors. Now, to set the stage for this challenge, let's look at two typical students sitting in the exam hall right this very second. We'll call them Alex and Sam. Now, Alex is that student who overloads every single answer with raw, unfiltered facts. Alex will write massive paragraphs about exactly how a light-dependent resistor works on a molecular level, but provides literally zero analysis of the actual greenhouse scenario the examiner gave them. Then we have Sam. Sam is constantly fighting the clock, rushing through the paper in an absolute panic, and completely missing specific command word requirements. Sam ends up writing a really simple description when the examiner explicitly asked them to evaluate. In this session, I'm going to show you exactly how to avoid becoming an Alex or a Sam. We are going to completely transform your raw knowledge into a strategic system that guarantees marks. So, we have to start by addressing the ultimate paradox of this syllabus. Why do students who religiously memorize all the facts still fail the application questions when they get into the exam room? Let's analyze Alex and Sam's flawed answers, which are bleeding marks as we speak. For a question about an automated climate system, Alex wrote, "A temperature sensor measures heat and sends it to the computer. A light sensor measures light. The computer turns on the heater." Now, this is a classic trap. It shows foundational knowledge, sure, but it completely fails to apply that knowledge to an unfamiliar context, like an automated chemical plant or a smart agricultural system. The examiner isn't just asking what a sensor is, they are asking how it functions within a specific, continuous feedback loop. You see, textbooks teach these concepts in isolation, but these Cambridge exams test them in integration. Sensors literally do not exist in a vacuum. They constantly interact with analog-to-digital converters, microprocessors, preset values, and actuators. If you just define what the sensor does, you are only scratching the surface layer of dirt. You haven't dug up the whole fossil yet. Here is our clear, step-by-step roadmap for today's session. Consider this an insider's guide straight from the principal examiner reports. We're going to cover the core principles, the top 3 mistakes to avoid, a foolproof 5-step methodology, data interpretation, critical analysis, and finally, my absolute favorite, the method mark strategy. Let's move right into Section 1, Core Principles. Before we can even begin to tackle complex, scary scenarios about UV sensors in automated water treatment plants, we absolutely need to understand the rules of the game. The examiners are testing very specific cognitive domains. They want to see systematic analysis. They want to see evidence-based reasoning. The assessment objectives, or AOs, are literally the DNA of your exam paper. AO1 is knowledge and understanding. This is the basic stuff, like defining what continuous data actually is. Then we step up to AO2, which is application. This is where you explain how a microprocessor uses data from a specific light sensor to determine if a street lamp should be turned on. And then we reach the top tier, AO3, analysis and evaluation. This is where you are comparing, say, a pressure sensor to a temperature sensor in a critical safety monitoring context. To get those top grades, you must hit all 3 domains by decoding the command words. If the question says describe, you are in AO1 territory. If it says explain how, you are operating in AO2. If it demands that you evaluate, you better be bringing your AO3 critical thinking skills. The absolute secret to hitting these objectives is integrating cross-topic connections. And we do this using the PEEL framework: point, evidence, explanation, link. Top-tier students structure every single answer using PEEL. So let's do a quick 30-second challenge right now to test your instincts. Think about 2 potential answers regarding a temperature sensor in a smart home. Answer A just says the sensor reads the heat and tells the heater to turn on. But answer B explicitly connects the analog sensor to the analog-to-digital converter, then to the microprocessor, and finally to the actuators. It states the point, provides the evidence of the ambient temperature, explains the microprocessor comparing data to a preset threshold, and links it directly to the actuator turning the heater on. If you intuitively know answer B is the winner, you are already on the right track. That explicit cross-topic linking is how you secure top marks. Now, before we continue to the really advanced strategies, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving on to Section 2, Top 3 Common Mistakes. Let's take a look at the dark side of the exam room, the insidious traps that consistently trip up even the most well-prepared candidates. We have synthesized hundreds of pages of Cambridge Principal Examiner reports so you don't have to waste your time doing it. Year after year, the senior examiners complain about the exact same things when it comes to Section 3.1. Let's break down these 3 specific mistakes. By understanding these, you're going to watch your potential red pen marks transform into beautiful green check marks as we correct them. We call this our computer science success blueprint. Mistake number 1 is using the wrong approach for the context. Listen, if the question asks about a UV sensor monitoring water purity, you absolutely cannot write an answer about a UV sensor detecting counterfeit money. The underlying physics might be somewhat similar, but the context is everything to the examiner. Mistake number 2 is completely forgetting format and presentation. When you are asked to structure data or provide a comparative table between analog and digital sensors, don't write massive, unreadable blocks of text. Use clear headings. Use bullet points. Make it easy for the examiner to give you points. And mistake number 3 is writing answers that totally lack specificity. Writing something like, "The sensor sends data to the computer," is a guaranteed 0-mark answer. Instead, using our blueprint, you must say, "The analog temperature sensor captures continuous physical data, which is converted to discrete digital signals by the analog to digital converter before being transmitted to the microprocessor." See the difference? That is a top-tier transformation. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Now for Section 3, the 5-step methodology. So how exactly do we fix those common mistakes systematically? By using a standardized sequence to guarantee you hit the exact requirements every single time. Let's do a speed writing workshop and apply these 5 steps together. Imagine a question asking how a pressure sensor is used in an automated burglar alarm system. Step 1, identify your key elements. In this scenario, we have a pressure sensor, an analog to digital converter, a microprocessor, and an alarm actuator. Step 2, apply principles. We know the sensor reads continuous physical weight on a floor pad. Step 3, execute your analysis using the PEL framework. Make your point, provide the evidence of the weight threshold, explain the microprocessor comparison process, and link it directly to the alarm triggering. Step 4, verify. Did you actually answer the specific command word asked in the prompt? And Step 5, present correctly using clear, syllabus-approved terminology. I challenge you to take 30 seconds after this explainer to draft that exact paragraph yourself. If you explicitly state that the microprocessor compares the incoming digital value against a stored preset value, you've just written a perfect PEL paragraph instead of a weak 1-mark sentence. Let's dive into Section 4, Mastering Data Interpretation. In the exam room, you are frequently going to be presented with incredibly complex data tables showing real-time outputs from multiple sensors simultaneously. It's time for a 60-second data scan challenge. Imagine a complex dataset from an automated greenhouse. Column A shows light intensity, column B shows temperature, and column C shows the status of the roof vents. Your job is to extract the core trend. When you scan the data rows, you'll notice a causal relationship. When light intensity is high, the temperature rises. When the temperature crosses exactly 28 degrees Celsius, the roof vent status changes from closed to open. The microprocessor is clearly using a hard threshold trigger. So the core trend you need to extract and write down is, the system utilizes an evidence-based feedback loop, where a temperature reading exceeding the 28-degree threshold caused by high light intensity triggers the actuator to open the vents. If you can confidently articulate that relationship, you have totally mastered data extraction, and you are racking up the points. Section 5, Critical and Comparative Analysis. Let's explore the exact difference between an average candidate's response and a top-tier evaluative answer. We're going to do a quick Find the Flaw challenge. Consider this flawed sample paragraph comparing UV sensors to temperature sensors in a weather station. The temperature sensor is better because people want to know how hot it is. Take a second to think about why that loses marks. Well, the examiner commentary on a response like this would be absolutely brutal. It fails to use comparative connectives, and it draws a highly subjective, completely non-evidence-based conclusion. Here is what a top-scoring candidate writes instead. Both the temperature and UV sensors provide continuous analog environmental data to the microprocessors. However, while temperature sensors trigger immediate physical reactions, UV sensors are typically used for long-term data logging. Therefore, their relative importance depends entirely on whether the system's goal is immediate automated climate control or long-term environmental data analysis. Boom. You questioned the assumption, you identified similarities and differences using words like however and while, and you justified your conclusion beautifully. Which brings us to Section 6, the method mark strategy. I want to present the complete answering system to you. There are 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, Peel framework application. And Rule 3, the time management matrix. But what happens if you just get stuck? What if the logical conclusion completely escapes you in the intense heat of the exam room? Showing your clear notation and working is your absolute ultimate safety net. This is the method mark strategy. In Cambridge computer science exams, the process is often worth significantly more than the final product. Let's say you were asked to design the logic for a complex feedback loop involving pressure sensors on a train track, and somehow your final conclusion is totally backwards. If you panic, rush, and just write down the final wrong answer, you get 0 marks. But if you document your systematic processing, noting that the pressure sensor captures analog data, noting that it requires an analog to digital converter, and noting that the microprocessor compares that digital data to a stored preset value, you could literally get 3 out of 4 marks on a question where your final conclusion was 100% wrong. Never, ever leave a blank space. Always write down the mechanism of the sensor, the conversion of data, and the role of the microprocessor. Just look at how far we've come today. We started by looking at the flawed, panic-induced answers of Alex and Sam, and we have systematically reconstructed a masterclass in exam technique. You now possess the exact step-by-step blueprint that the senior examiners are begging to see. Students who actually implement these specific computer science strategies see an average improvement of 2 whole grade boundaries. But that is only if they practice consistently with our weekly sessions. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCS and click that bell. Don't let another exam pass you by. So I leave you with this final critical thought. How are you going to apply this 5-step methodology to completely transform your next past paper? Drop a comment below with your target grade for computer science and the biggest challenge you're currently facing. Our team responds to every single comment. Like and share this with a study partner. Ace the Exams. Your Cambridge success starts here.